Welcome back everyone to Let's Learn Calculus Part 3. Today we're going to look at polynomial functions. So we're going to look at finding roots, determining end behavior, and the number of turning points of polynomial functions. So to begin, what is a polynomial? Examples of polynomials are something like x squared minus 2x plus 7, pi times x to the 217 plus ex squared minus 400, or just 0. So formally, a function f is a polynomial if it is an times x to the n plus an minus 1 times x to the n minus 1 plus a bunch more stuff in between times a1x plus a0, where ai is a real number. So each of these an minus 1, a1, a0 are just real numbers, and we call those coefficients. An not equal to 0 is the leading coefficient, and a0 is a constant term. The degree of the function, n, is a non-negative integer. So the big three things about polynomials. When we're working with polynomials, we'll mostly concern ourselves with the roots of the polynomial, which is the x values where f of x equals 0, the end behavior, and the number of turning points. So if we're looking at the roots of a polynomial, the roots of a polynomial are the values of x so that f of x equals 0. So in this section, we're only going to consider linear equations and quadratic equations, though we can also consider cubic equations and up. So if f of x is equal to ax plus b, just a linear equation, the roots are x is equal to negative b divided by a. And we get that just by setting f of x equal to 0 and solving for x. Now if f of x is a quadratic, ax squared plus bx plus c, we have the quadratic equation will give us the roots, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So example 1 asks us to find the roots of the polynomial f of x is equal to 3x squared minus 7x plus 1. And we will do this by the quadratic equation, which says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, here we have a is equal to 3, b is equal to negative 7, and c is equal to 1. So x is equal to negative 7, which is 7, plus or minus the square root of b squared, which is 49, minus 4 times 3 times 1, all divided by 2 times 3, which is 7 plus or minus the square root of 49 minus 12, which is 37, all divided by 6. So our roots are x equals 7 plus the square root of 37 divided by 6, and x is equal to 7 minus the square root of 37 divided by 6. Now we're going to look at the end behavior of a polynomial. The end behavior of a polynomial f is given by the leading coefficient test, which states if the degree of f is even and the leading coefficient is positive, then the graph rises to the right and rises to the left. If the degree of f is even and the leading coefficient is negative, then the graph falls to the right and falls to the left. If the degree of f is odd and the leading coefficient is positive, then the graph rises to the right and falls to the left. And if the degree of f is odd and the leading coefficient is negative, the graph falls to the right and rises to the left. And I know this sounds like a lot to keep straight, but really if you can just keep these four functions in your mind, it all makes perfect sense. So the first one we're going to look at is f of x is equal to x. So what we have here is something like this, where this is degree 1, and the leading coefficient is positive, so it falls to the left, rises to the right. Here we have negative x. It's also degree 1, and the sign is negative, but it rises to the left and falls to the right. For the third one, we have f of x is x squared, which is degree 2, and the sign is positive, so it rises to the right and rises to the left. And finally, we have f of x is negative x squared, which is also degree 2, and the leading coefficient is negative, so it falls to the right and falls to the left. Now, we also look at the number of turning points. So another important consideration when working with polynomials is the turning points. At this time, we don't really have any way to find the turning points, but we can put an upper bound on the number of them. So the number of turning points in a graph of a polynomial of degree n is at most n minus 1. So let's just think about this real quick. F of x equals x is degree 1, and it has 0 turning points. g of x is equal to x squared has degree 2, and it has one turning point. H of x is equal to x cubed has degree 3, but it doesn't have any turning points. And p of x is equal to x times x plus 1 times x minus 1 has degree 3, and it has two turning points. Example 2 asks us to determine the end behavior and the number of turning points of the function f of x is equal to x times 2x minus 4 times x plus 7 squared. Well, if we multiply this out, we would find that the leading term is 2x to the fourth, which means that our leading coefficient was equal to 2, and the degree was equal to 4. So because the degree is equal to 4 and the leading coefficient is positive, the end behavior we have it rises to the right and rises to the left. And we also have that the number of turning points is at most 3. And that does it for this video. If you liked the video, hit the like button. If you have any questions, feel free to leave a comment. And we'll see you guys in the next one.